Dear students, continuing with our lecture series on named reactions, this is our 42nd lecture, and today we will discuss what is Swern oxidation. Swern oxidation is an important reaction for the oxidation of primary and secondary alcohols to aldehydes or ketones. And the advantage of Swern oxidation is that this is not affected by the steric hindrance of different groups present on the substrate molecule, and we can get selective products after the oxidation process. In this process, the reagent which are used for the oxidation, they are a combination of trifluoroacetic anhydride or oxalyl chloride with DMSO. They act as reagents for this transformation of alcohols to aldehydes or oxidation of primary and secondary alcohols to aldehydes or ketones respectively. So basically what happens is when at a low temperature of the order of minus 60 degrees centigrade, that is below minus 50 degrees centigrade, when dimethyl sulfoxide is reacted with trifluoroacetic anhydride, then at this low temperature they give us an intermediate, that is trifluoroacetoxidimethylsulfonium trifluoroacetate, and this intermediate formed then reacts with the alcohol to oxidize these alcohols to aldehydes or ketones. And once this intermediate is formed, trifluoroacetoxidimethylsulfonium trifluoroacetate, then we add the substrate, that is primary or secondary alcohol. And after some time, when the reaction mixture is reacted with triethylamine, that is any tertiary amine, and most commonly used is triethylamine, or even diisopropylamine is also used as a tertiary amine. So when this is added, then the this resultant alkoxidimethylsulfonium trifluoroacetates, they decompose to give us the corresponding aldehydes or ketones. Uh, then this reaction was discovered in 1976, but they suffer from certain side reactions, and then in 1978 a modification was done. Modification means instead of TFFA, oxalyl chloride was used for this reaction, and it was found that oxalyl chloride was found to be more uh, potent activating agent for DMSO in the oxidation of alcohols than TFF. So with oxalyl chloride, there were only few side reactions, whereas with TFFA, fumarate rearrangement products, they were also formed if the temperature of the reaction comes out below 50 degrees centigrade. These are the general features of Swern oxidation. It was found that when no solvent is used, then DMSO will react with TFFA or oxalyl chloride very violently, and even an explosion may take place. Therefore, for Swern oxidation, we need to use some organic solvent for the reaction to take place. And the most common solvent which is used for most of the Swern oxidation reactions, that is dichloroethane. Then another general feature of Swern oxidation is that when TFFA, that is trifluoroacetic anhydride, is used, the intermediate which is formed by the reaction of TFFA and DMSO that is unstable above minus 30 degrees centigrade. Therefore, the temperature of the reaction should be below minus 30 degrees centigrade, and that side product is formed via tubular rearrangement, which I have already told you. Similarly, if instead of TFFA we used oxalyl chloride, then initial intermediate is unstable above minus 60 degrees centigrade. So here that is why most of the oxidation process is conducted at minus 78 degrees centigrade when we are using oxalyl chloride as one of the reagents. As far as procedure of this reaction is concerned, as I've told you, first we will add DMSO with TFFA or oxalyl chloride at low temperature. In case of TFFA, usually at minus 50 degrees centigrade, whereas with oxalyl chloride minus 78 degrees centigrade. Then after this we slowly add alcohol to the reaction mixture, and after some time we add tertiary amine to the reaction mixture to decompose the intermediate form during the reaction. As I have told you, any tertiary amine can be used, and most commonly used they are diisopropylamine or triethylamine. So they will facilitate the decomposition of alkoxysulfonium salt, which is formed at the initiation of the reaction. And another feature is that efficiency of the oxidation is not affected by steric hindrance of the substrate. As I have told you, that steric hindrance does not affect the Swern oxidation products. And TFFA may give trifluoroacetate as the side product, whereas side reactions are extremely rare when we use oxalyl chloride. So overall, oxalyl chloride in combination with DMSO is more effective reagent for Swern oxidation than TFFA and DMSO. Now, as far as mechanism of this reaction is concerned, as I've told you, first mechanism is with TFFA as the activating agent with DMSO. So, DMSO will react with TFFA to give us these types of alkoxysulfonium salts. And these salts, if temperature is below 30 degree, then they will react with the alcohol, and through decomposition of these reagents this will lead to the formation of ketones as the product. But if the temperature is more than 30 degrees centigrade, as I've told you that these intermediates they are not stable, then they will undergo side reactions through rearrangement. So this is how the alcohols they can be converted into aldehydes or ketones. So primary alcohols they will give aldehydes, secondary alcohols they will give ketones as the product through alkoxysulfonium yielded as the intermediate. Similarly, if we use oxalyl chloride, then also in the first step the reaction will take place at minus 78 degrees centigrade. So at this low temperature, DMSO will react with oxalyl chloride to give us these types of sulfonium salts, intermediates, and then the chloride ion which is removed that will attack the sulfur, and we will get chlorosulfonium salts which will react with the primary or secondary alcohols, and rest of the mechanism is same as we have seen in case of TFF. So these chlorosulfonium salts on reaction with alcohols, they will be converted into alkoxysulfonium salts, and these alkoxysulfonium salts on reaction with tertiary amines, this will abstract this proton and alkoxysulfonium gelates will be formed, and then these gelates they will undergo rearrangement to give us or decomposition to give us aldehydes or ketones as the product. Then there are many applications of Swern oxidation, and most important applications is that Swern oxidation is used as one of the steps for the synthesis of many types of biologically active substrates. For example, uh, uh, the Swern oxidation was one of the steps in the first total synthesis of marine dolabelline diterpene, that is deoxyneodolabelline. This one, this marine diterpene derivative was synthesized where one of the steps involved was Swern oxidation. So basically, this is a alpha hydroxyketone, and alpha hydroxyketones they can be synthesized through various methods, but oxidation of 1,2-diols to alpha hydroxyketone was one of the steps in the synthesis of this marine diterpene. So many methods were tried, like Des-Martin or Ley oxidation for conversion of 1,2-diols into alpha hydroxyketones. But these methods they led to the cleavage of the carbon-carbon double bond over here, and instead of alpha hydroxyketones, we got aldehydes and ketones at these carbons. So, because Des-Martin and Ley oxidation failed to give us alpha hydroxyketones, then it was tried through Swern oxidation. So, when Swern oxidation of these 1,2 dihydroxy derivatives, this consisted of four diastereomeric diols A, B, C, and D. So basically, when these mixture, which is not separable during the synthesis of this diterpene, when this was treated with oxalyl chloride in DMSO using dichloromethane as solvent and triethylamine as tertiamine at low temperature of the order of minus 78 degrees centigrade, then it was found that 65% of alpha hydroxy ketone, that is deoxyneodolabelin, was formed with 8% of the other enantiomer which is formed. So, Swern oxidation was successful in producing the desired compound through oxidation of only one of the hydroxyl groups to ketones. So, we have been able to selectively oxidize one of the two hydroxyl groups. Then similarly, another application is in the synthesis of iracenyl A, and this is iracenyl A. This is again a benzamine alkaloid, and this was synthesized through a double Swern oxidation. So when this type of dialcohol, both these groups they are primary alcohols. So when this substrate was treated under Swern oxidation conditions, it gave the corresponding dialdehyde in 89% yield. So, very effective reaction for conversion of this alcohol into the dialdehyde. Now, then this dialdehyde was subjected through Witting reaction. This phosphorylate was used for the conversion of these ketones into these alkenes. So this uh, terminal alkenes they were formed, and through different reactions they were further converted into its which is very important biologically active mesamine alkaloid. Then another application is in the synthesis of acetyltoxin, which is a myotoxic compound, and synthesis of this is achieved through Horner Wordsworth Ammons olefination, which is popularly known as HWE olefination. Now, before this olefination can take place, basically this olefination is between the reaction of base tetrahydrofuranaldehyde with this type of alpha pyrrole phosphonate. So when these two they are reacted under these conditions, HWE olefination, then a carbon-carbon double bond is formed between the aldehyde and this carbon. So basically, under the conditions of HWE olefination, a carbanion is generated at this place, and that carbanion will attack the carbon of the aldehyde, and basically carbon-carbon double bond will be formed. So this is how this aldehyde is converted through HWE olefination into acetyltoxin. But this aldehyde is synthesized from this alcohol through Swern oxidation process. And advantage is that if we start with this alpha stereocenter, this does not epimerize to give us a mixture of these two. Instead, we will get a alpha product in 95% yield. So, stereoselective synthesis of this aldehyde is achieved through Swern oxidation process. Then synthesis of 11-deoxydinomycinone, which are these types of anthracyclines. They are biologically very active, and some of the compounds of these types they possess anti-tumor activity. So that is why, because of the biological activity, the synthesis of these types of compounds is important. And during the synthesis of these types of dinomycin derivatives, Swern oxidation is one of the important steps in synthesis of such types of compounds. So when this type of triol was reacted under Swern oxidation process, oxalyl chloride DMSO at minus 60 degree followed by triethylamine, then the oxidation of these two hydroxyl groups took place selectively, because these are the secondary hydroxyl group, whereas the third hydroxyl group is not affected because this is a tertiary hydroxyl group, and the product formed is 81%. So this is an important reaction for the synthesis of such type of compounds. Similarly, these types of natural products, here also alpha hydroxy nitriles, they are also selectively oxidized to the corresponding ketones without affecting the nitrile group under Swern oxidation conditions. Then this Swern oxidation was also an important step, Swern oxidation, in the synthesis of quinine. So in the first stereoselective total synthesis of quinine, This Swern Oxidation was one of the important steps when this type of azido alcohol, that is, which is a mixture of the two epimers alpha and beta. When a mixture of this two epimers of azido alcohol was reacted under Swern oxidation conditions, then it was converted into this azido ketone in 85% yield. And then through further steps, this azido ketone was converted ultimately into quinine, and even the corresponding epimers of quinidine, they will lead to the formation of the azido ketone, corresponding azido ketone, and that will lead to the synthesis of quinidine also. Quinine and quinidine, they are two enantiomeric compounds. Uh, Similarly, these types of hydroxy compounds, these are again some natural products. Under Swern oxidation conditions, they are converted into the corresponding ketones, and these SLIET ethers, as the substituent, they are not affected, and no oxidation of these SLIET ethers take place, and selectively only this secondary hydroxyl group is converted into the ketone. Next application is in the synthesis of Mark uh, Mark 14A, that is these types of alkylidal compounds. So basically, this compound 14 alpha hydroxy Mark 14A MFA, this is a biologically active compound, and here the configuration of this hydroxyl group is alpha, and it was thought to synthesize its antipodes. It was tried to synthesize the beta derivative of the same compound, that is conversion of A into C. So basically what was done in the first step, the Swern oxidation of this alpha hydroxy 14 alpha hydroxy compound uh, led to the synthesis of this B, the corresponding ketone, and this ketone was biologically inactive. This is formed in 74% amount. And when this ketone is reduced with sodium borohydride, then we got 50% of beta 14 beta hydroxy Mark 14A, and 3% of this starting material, that is 14 alpha hydroxy. So basically a reduction of this ketone led to the formation of uh, 14 beta and 14 alpha product, whereas 14 beta was formed as the major product in 50% amount, but it was found to be biologically inactive in comparison to A. Then it was thought to synthesize the methyl derivative of this alpha hydroxy. So it was reacted with the methyl magnesium bromide. Reduction of this ketone was done through Grignard reagent. So this led to the formation of this uh, 14 beta methyl and 14 alpha hydroxy Mark 14A, that is MFA. This was synthesized, and 50% product having this hydroxyl in alpha position was synthesized, and it was found to be biologically active, as was the starting material. So we can synthesize many types of uh, biologically active compounds through Swern oxidation. Then few modifications of conditions in Swern oxidation. So, if instead of primary or secondary alcohol, we use aryl alcohols. This is allylic alcohol, and this is aryl part. And when this is reacted with oxalyl chloride or oxalyl bromide, both can be used. Then alpha halo ketones, they were synthesized as the product. So, in case of primary and secondary alcohols, we have seen the corresponding carbonyl compounds are formed, that is, aldehydes or ketones are formed. Whereas in case of allylic alcohols, we will get alpha halo ketones as the product, and this is called as Moffat's-Swern oxidation, and this is a modification of Swern oxidation. So modification is in the substrate. Similarly, the modification of the substrate can also be done. So if instead of primary or secondary alcohol we used amides or oximes under Swern oxidation conditions, then both of these, they were converted into the corresponding nitriles instead of aldehydes or ketones. So amides or oximes, they are oxidized to nitriles under Swern oxidation conditions. So this is another modification of Swern oxidation. Then one more modification is which is called as Korekim and Swern oxidation combining the primary or secondary alcohols. They were oxidized where we used these types of sulfides instead of DMS. So do-decyl methyl sulfide was used instead of DMSO, and this in combination with oxalyl chloride led to the formation of corresponding aldehydes and ketones. So this is the modification part, that instead of DMSO we used sulfides. Similarly, instead of oxalyl chloride or TFFA, we use these types of cyclopropenium halides. So 2,2-dichloro 1,3-diphenyl cyclopropene was used as an activator for DMSO, and this is again the product formed is again primary and secondary alcohols, they are converted into ketones. Only thing is that the intermediate formed by this cyclopropenium halides with DMSO will be different, but ultimately lead to the formation of same type of products. So this is another modification of Swern oxidation. So these are the references which have been used for preparing this lecture. You can contact me. All the details are given over here. Thank you very much.